Look up at any modern skyscraper, office building, or even a new residential home. That sleek, reflective facade, those slim, durable window frames, chances are you're looking at aluminum. This metal has quietly revolutionized construction, enabling the glass-dominated aesthetic that defines our cities. But why aluminum? What makes it so much better than steel, wood, or PVC for so many applications? The answer lies in a nearly perfect combination of properties. It's incredibly light, it's strong, it's naturally resistant to corrosion, and it can be formed into almost any shape imaginable. In this video, we're going to shed light on the unsung hero of modern construction. We'll explore how aluminum is mined, alloyed, and manufactured into the components that shape our built environment. We'll break down its advantages, its limitations, and the critical engineering details, like thermal breaks, that make high-performance aluminum systems possible. By the end, you'll understand why this material is a cornerstone of contemporary design. Let's start with the fundamental properties that make aluminum a construction superstar. First and foremost is its strength-to-weight ratio. Aluminum is about 1/3 the weight of steel, yet certain alloys can approach the strength of some structural steels. This means you can create large, strong components like a curtain wall mullion that are much easier to transport, handle, and install, reducing the load on the building structure. The second game-changing property is its corrosion resistance, and like steel, aluminum doesn't rust. When exposed to air, it instantly forms a thin, hard layer of aluminum oxide on its surface. This layer is self-healing and protects the metal underneath from further degradation, making it ideal for exterior applications without the constant need for paint. However, for architectural uses, we almost never use pure aluminum. It's too soft. We use aluminum alloys, where elements like silicon, magnesium, and manganese are added to dramatically increase its strength, hardness, and workability. The most common series for construction are the 6000 series alloys, like 6061 and 6063, which offer an excellent balance of strength, corrosion resistance, and, most importantly, extrudability. This leads us to aluminum superpower extrusion. This process is what makes aluminum so versatile. It involves heating an aluminum billet and forcing it through a shape die. Much like squeezing toothpaste out of a tube, the result is a long, continuous profile with a precise cross-section. This is how we create complex shapes for window frames, curtain wall mullions, roofing systems, and custom architectural details. The design possibilities are virtually limitless. A pro tip for architects and engineers is to design extrusion profiles with manufacturability in mind. Consistent wall thicknesses and generous RD make for a stronger, higher quality, and more cost-effective part. A common drafting mistake is to design a highly complex profile that looks great on screen, but is impossible or prohibitively expensive to extrude efficiently. Now, let's look at the store applications. The most visible use of aluminum is in the curtain wall. This is the non-structural, outer skin of a building, and aluminum is its perfect skeleton. The system consists of vertical members mullions and horizontal members transoms that are fastened together to form a grid. This grid is then filled with panels of glass, metal, or stone. The aluminum frame is strong enough to support these heavy infill panels and resist wind loads, yet light enough to not overburden the building's primary structure. Another ubiquitous application is in windows and doors. Aluminum allows for much slimmer sightlines than wood or UPVC, maximizing glass area and views. Its dimensional stability means it won't warp, swell, or rot, ensuring consistent operation for decades. However, aluminum has a critical weakness: it's an excellent conductor of heat. This is a major problem for building energy efficiency. A standard aluminum window frame would act as a thermal bridge, freely transferring heat between the interior and exterior, leading to condensation, energy loss, and discomfort. The brilliant solution is the thermal break. This is a strip of a non-conductive material, typically a polyamide, that is mechanically locked into the aluminum extrusion during manufacturing. It literally breaks the path of thermal conduction, separating the inner and outer parts of the frame. A high-quality, thermally broken aluminum window can perform as well as or better than wood or vinyl. This is a non-negotiable feature for any modern, energy-efficient building in a climate with heating or cooling demands. Finally, we can't ignore the finish. While the natural silver finish of aluminum is popular, we often apply surface treatments for aesthetics and added durability. Anodizing is an electrochemical process that thickens the natural oxide layer, creating an extremely hard, durable, and integral finish that is resistant to wear and corrosion. It can be clear, bronze, or black. Powder coating involves spraying a dry polymer powder onto the aluminum and then baking it to create a tough, flexible, and uniform coating. It offers a virtually unlimited color palette and is highly resistant to chipping and fading. A sustainability standpoint. Aluminum is also highly recyclable. Nearly 75% of all aluminum ever produced is still in use today. Recycling it requires only about 5% of the energy needed to produce primary aluminum, making it a truly green building material. To summarize the key takeaways: 1. Aluminum's high strength-to-weight ratio and corrosion resistance make it ideal for structural and exterior applications. The extrusion process allows for incredible design flexibility and complex profiles. 3. Its use in curtain walls and windows defines modern architecture. And 4. The incorporation of a thermal break is essential for overcoming its high thermal conductivity and achieving energy efficiency. Now I want to hear from you in the comments below. What's the most innovative or impressive use of aluminum you've seen in a building project? Was it a complex custom extrusion, a massive curtain wall, or a clever retrofit? Your examples help illustrate the power of this material. If this deep dive into aluminum has been valuable, please give this video a like and subscribe.